Good morning. I wanted to say good afternoon, everyone. Uh, we are in Theatre 2. My name is Marinda Hall, and I am the moderator of this theatre. I was here yesterday, I'm here today, and tomorrow here as well. We have an audience here live in Amsterdam, in the Rai, but we also have an audience through our recording. So a special welcome if you are looking at our recorded session. And for you here live, if you have missed a session here in Theatre 2, you can look it up through the app, and it's all available later on, so you'll see that later. We have Bob Ransdorp here today. I'm saying that in Dutch. Bob Ransdorp in English, from Royal Haskoning DHV, and he's going to tell us about optimizing traffic through cloud technology. And we've spoken about the challenges we as a society are dealing with, and he's going to focus on greener and cleaner cities. So, ladies and gentlemen, I see a lady there, hi. May I have a warm welcome for Bob Ransdorp. Can I have a warm welcome for Bob? Yeah. Great. Thank you.
Yeah.
I'll be back here with a microphone later on for questions from the audience.
Great.
You have your clicker. Are you okay?
Yeah. We just have a small technical issue.
Small technical. Everything okay, Vincent? Okay. Oh, it's like this. Comme ci, comme ça. I see.
Yeah.
Okay. If there's problems, I'm here.
Good.
Vincent's here. We've got your back.
Great.
Take it away.
Okay. Thank you all, and welcome. You were actually supposed to see a colleague of mine, Gert Hut, but he's unfortunately ill, post-COVID kind of thing, as you probably know. So you have to do it with me. So please bear with me. I'll do my best. Just like what I'm going to tell you, being adaptive. We try to do that as well by presenting you these topics. Today I'm going to talk about how you can leverage cloud technology to optimize your traffic management, and in that way create cleaner and greener or more livable cities. I'm going to do that by a software proposition that we have developed over the years called Flowtech, which is a proactive, future-proof mobility management solution that leverages cloud technology as other technologies to optimize mobility policy or environmental policies. I will walk you through a bit of trends, but probably we all know them. Later on, I will talk to you more about the technology or the software proposition that we have developed, and I'll show you some examples of what kind of results are able by using this type of software and leveraging the technologies like cloud technology in order to optimize a network by implementing policies on the network itself. Now, quick introduction on Royal Haskoning DHV. We are actually we were last year existing for 140 years. We're a private company owned by the employees itself. We're about 5,000 to 6,000 people. We're working all over the world in various markets, one of them being traffic management. Now, I'm going to quickly go through the next slides, as you probably can dream about these. Well, I can, and I hope you as well. Nowadays, we have more and more urbanization, so growing cities. It's getting busier. Climate change is a challenge for road authorities or for all of us. And there's more and more data available. And what we see within our company, who's dealing with a lot of governmental organizations that have certain traffic management solutions, etc., or try to implement their policy, is that they get a lot of more data, but they don't know how to leverage it. Well, we try to help them and basically battling these type of challenges for mobility policy. Oh, sorry, for traffic management. Why? Because traffic management is actually one of the solutions for these challenges. If you want to optimize the usage of existing road network, if you want to lower emissions, if you want to leverage data, then traffic management is a way to use and make a efficient and effective road network working. Now that's not new. This is a picture that is being shown to you, which actually hangs or is being shown in the Smithsonian National American History Museum in Washington, and it originates from the 1970s. So already for about 50 years we're thinking of, okay guys, there are things happening on the road, we have certain assets, they are producing data, what if we could bring that all together? Now 50 years later, finally we are getting there on a national basis or on a nationwide basis, at least here in the Netherlands, but also now in Belgium, and other European countries are following. So what has been done a couple of years ago, a supply chain on a national basis was created in order to connect traffic lights, a traffic management instrument, to data coming from connected users via information services. Now that really works because if you are able to connect the creators of the problem, you, me, road users or mobility users, if you are able to connect them to the responsibilities and the policy of a road authority, you make them becoming part of the solution. And that has never been done on a nationwide basis. So here in the Netherlands, and like I just said, in Belgium, there's now a supply chain which makes it a nationwide supply chain, and that scale makes it very interesting for the industry to start working. Proof of concepts, tests, etc. are always interesting, but for really having the industry adapt to it, start using it, you need to make it scalable. Well, that has now been created here in the Netherlands, and with that, the supply chain itself, the network, the fully connected network, you are now able, by using cloud technology, among other technologies, to start to really think, okay guys, as a road authority, what do I want to see on the roads, according to what are the rules of engagement, let's say, where road users or mobility users, because this is also for trams or for airports applicable, what do I want to see? What are my responsibilities in terms of environment, in terms of mobility, in terms of safety, and how can I have that implemented on the network itself? By having the users of the network becoming part of the solution. Now, I think I'm going to show you what I just said. I think I'm going to show you here. Traditional mobility policy. How can I describe it? What I always hear is that there's a lot of silos. There's someone who's making the policy, then someone else or a group is making the action plan, and then last but not least, there's the traffic operator who somehow needs to get these two together and figure out what a traffic light controller should be doing. And why am I focused on traffic light controllers? If you talk about traffic management, there is no other instrument that is so effective and efficient, or at least can be so effective and efficient as a traffic light controller. Why am I saying that? Well, just look at yourself. I presume everybody here stops for a red light and goes when it's green. So there's no other type of asset management or asset, there's no other type of instrument that has such a result in terms of being efficient and effective. If you are able to connect the policy, the action plan, and the asset itself, the traffic management instrument, the traffic light controller, with each other. That's what you see here. Now, that is something that we have been doing here in the Netherlands, and Royal Haskoning DHV has created the software for that. So we have the on the lower left, you have the data creators, the problem creators that are creating data that is being captured in a national supply chain, and that data is being made available to the software that basically implements the policy and feeds that back to the road users or the mobility users. And in that way, you are able to have the road users or the problem creators make them part of the solution by adopting the policy that a road authority who is responsible for that network by adopting that policy. That's why we said, okay, the Flowtech software proposition, the ITS application that we have created, it's not about programming parameters. If you happen to have experience in traffic light controllers, then sometimes, yeah, it feels like coming up, trying to solve a puzzle. And sometimes the puzzle has more than 3,600 parameters, where you can all tweak a bit, like, okay, give this a little bit more green time, and maybe that I want to continue, or I want to have that section stopped much earlier, and then, okay, then there's the traffic jam at in the mornings, and I have a schedule for the evening, and somewhere in between. So there's a lot of different parameters that you can tweak on. Now, we have a lot of experience with that, but having more and more data becoming available, having more and more challenges in terms of the policy, so what the road authority actually would like to see, this is becoming not workable anymore. So we created a software solution using cloud technology where you can just configure the policy. So please, dear road authority, give us your policy. What do you want to see on the roads in terms of, do you think bicycles are important, or public transport, or both? What do you would like to see when certain, a truck of certain trucks are coming along? What do you want to see at those things? And then let the software take care of it. So instead of being active, or let's say reactive, you become proactive as a road authority by laying down the rules. So these are a couple of characteristics where the software has been based upon. So it's policy driven, it's future proof, because we expect more and more data to come in the coming years. We already see nowadays sometimes 10% of the data going into the system is coming from connected users. So that will ramp up quickly, because only a couple of years ago it was 1% or less. So now we're already at certain sections, we see 10% connected data. That will go up and up and up. So you need to be able to use that data, and you can do that by using cloud technology. When you have that type of technology being used, you are also able to optimize things on a single section or on a corridor, so among various crossings or junctions, or even an entire network, like we have been doing, for example, in a city in the Netherlands here called Deventer. And it is hardware agnostic. So meaning we don't have to rely on the traffic light controller itself, the physical hardware. We are just in the cloud, and the cloud technology is the instrument to to steer the traffic lights itself. In terms of traffic management characteristics, this is what you see. So this is from let's say, from a policy perspective, that's what we aim for. From a traffic management perspective, we see everybody as equals, unless the road authority would like to see differently. And then, of course, it becomes a bit of a game with giving certain weights to certain type of road users, and based upon that, the traffic will start to flow. Now, going back to the cloud technology, cloud technology is great, but it's how you use it. We use it in such a way that we would like to know what is the policy. We configure that in the cloud, and every second, tens of thousands of calculations just on a single junction are being made to come up with the most efficient and effective schedule for the green patterns on that specific moment. Previously, that was always done. Okay, so on a modeling basis. So you took historical data, and you were going to watch. Okay, so based upon what we've seen in the past, probably this will work out. But as we all know, simulations, models, will never happen in reality because there's always something differently. Now, using cloud technology and all the data makes more or less these models, I'm not going to say obsolete, but makes them less important. So you are really able to steer and optimize traffic management and the road itself every second by using different data sources, feed that into the cloud, and then, according to the policy, have the green pattern being adopted. One other example, which you probably can already think of, if you're using cloud technology, you're also able to easily scale up. So we have been doing this on, like I just said, we've been doing this on a single junction. We could do this on a corridor, but we could also do this on entire networks. 1 or 40 or 200 doesn't really make a difference. So also that, in terms of installation time, usually this takes, in the old way, it can take years, really, to have the hardware installed, etc. The application itself, yeah, it's almost plug and play. I'm not going to say it is plug and play, but it can go very fast. Some examples of what we have been doing over the years. We're doing standalone junctions. We have been doing coordinated nodes with highways. This is actually in the Netherlands for the Rijkswaterstaat organization, which is the traffic authority on the national highways. We're doing even controlled roundabouts, but also, like I just said, corridors. This is a specific one. We haven't. This was released beginning of this year, and there we had a challenge. It's a very urbanized area, and we were forced, or we had to come up with some sort of solution or configuration of the technology itself. That there are, how do you say that, green waves, but the green waves had to become adaptive. Green waves, well, let's say the green waves 1.0 are really fixed. Yeah, so okay, we know, okay, we start here at second 1, and then 30 seconds later we'll give green at the next junction, etc., 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 based upon a historical data sample. That is currently not the case anymore with Flowtech. We are now able to adapt basically the green flows according to the policy needs, and that makes it more dynamic and adaptive according to what is happening actually right now on those junctions itself. So all the junctions start to talk to each other, And as you can imagine, for a single junction, we do about 10 to 20,000 calculations every second. Well, this is times, not times 8, but how do you say that? Up to the 8th grade, I think. I'm not sure how I need to explain that. Furthermore, some actual results. This is actually a city called Deventer, like I already mentioned. It's the only city right now in the Netherlands which has made the switch from the old traffic light controller technology to the fully connected traffic light controller technology. ITLCs is how we call them, intelligent traffic light controllers. Using multiple ITS applications, so among Flowtech from Royal Haskoning and HV, there's also ITS applications from other companies. The city itself has a diverse set of policy goals, and of course they went for this type of solution after they tested it, and we had a interesting test. That was this one. Not so long ago, a World War II bomb had to be dismantled just next to the highway where Deventer is located next to. So all the traffic had to go through the city. Now, usually that is quite a challenge for traffic engineers because that's a massive change in flow and as you can imagine also a massive increase of traffic itself. Now in the end Flowtech was able to adapt continuously to those changed patterns basically, or that changed demand of traffic, and it just worked out well. So this was also for us a very interesting stress test. In terms of different types of policies, because I can imagine every traffic authority has different types of policy goals. One of them is I want to keep traffic flowing. Of course, the other one is how can I increase or improve environmental issues, decreasing emissions, for example, improve safety. All of those things can be configured in the software itself because you're using cloud technology, and it will just work out. It will start to think every second, okay, I have this diverse set of goals, so in that way I can optimize things on the fly. This is an example where you will see the star coming in from the south, which is actually an emergency vehicle. It's an ambulance, which in a really safe way flows with the traffic through the network. We still in the Netherlands, and I'm sure this is worldwide, still a lot of emergency vehicles have accidents while they are trying to manage through traffic. Now, what if you're able to have those emergency vehicles flowing along the route itself with the surrounding traffic? Now that is possible if you start to connect traffic light controllers to each other, have them speaking to each other continuously on a 1-by-1 second using cloud technology. That is one of the leverage or one of the benefits of leveraging cloud technology. Some other goals are livability. So, like I just mentioned, use a lot of data, not trying to optimize one single junction, but do it on an entire network or on a corridor, like you here see. And one other cool thing is if you have a nationwide supply chain, then different type of applications can start to talk to each other. So like I just mentioned, Flowtech has a big stake in this network, but there's also software from other companies, and they are actually exchanging data with each other. So as a road authority, you have the benefit of using different types of applications, but that doesn't mean that they are not able to communicate with each other when you're using cloud technology with a supply chain, a nationwide supply chain, or at least a city-wide supply chain where things can be exchanged with each other. Some results that we have been able to create. Accessibility and livability go up a lot with the help of traffic management. With Flowtech, it is able to reduce emissions by double-digit numbers. And last but not least, and we haven't talked really about that, but there's also a massive amount of cost reduction possible. When you take out the software of the traffic light controller itself, it will reduce costs, and it also, how do you say that, is, well, you can update and you can service it over the air. So that doesn't mean that every time you want to have something changed, you need to go to the hardware itself as a road authority or as a supplier of the hardware. You can do it over the air, which is great. The results are shown below, some other results, but this is what we are hearing from a lot of customers, and we're happy to help them. I can still also talk a little bit about this. This is one concrete example of Deventer. They wanted to improve just like a lot of Dutch cities, but also I see this more and more worldwide. A lot of cities are trying to facilitate cyclists more and more. Why? Because it's a great mode of transport, and of course this is helping to reduce emissions and also make even the citizens itself much more healthy. With Flowtech, we have been able on a certain corridor to reduce the waiting time, so improve the cyclists of the flow of the cyclists with 27%, while that was actually being experienced as 30 to 40% of the cyclists. So making them the problem creators, making them part of the solution even helps them to become more positive to the road authority using this type of applications. And of course, it's very easy to improve the throughput of cyclists if you're cutting off, of course, other modes of transportation. So for us, the challenge was to improve the throughput of cyclists, but also at least keep the status quo for the other modes of transport. Well, luckily, we were even able to improve that as well. I'm going to keep it here because I see I don't have a lot of time anymore. First of all, I would like to thank you for your attention. You're welcome.
Let's give you a round of applause. Well done. Yeah, and it says vragen. That means questions. Does anyone have any questions? A question. Yes, I'll go to you first. Yeah. Could you introduce yourself, please?
Hi, I'm Pieter Jan. I'm working for a local government, and I'm a traffic light advisor. I was wondering the number, the 27% reduce of waiting time for cyclists. Yeah. How are they detected, and how are they taken into account? Because if you don't have every cyclist, and you make an operation system that makes them less waiting. Yeah. Yeah, it's a bit self-fulfilling prophecy if you don't have everyone. If you know what I'm meaning.
No, I definitely understand. What is important to know is that this was a independent evaluation. So we haven't done it ourselves because then, of course, it is in that the self-fulfilling prophecy that you would like to see. But this was done actually by another company, which was asked by the customer to do this. And they basically did an A/B testing. So they did a before study and an after study. And those great results came out of it. Does that answer your question? Yeah.
And then, go ahead.
And how are they detected, the cyclists?
Yeah.
Thank you.
Different in different ways. So they did interviews, so that's where the 34 to 40% of improvement experienced by the cyclists comes from. The 27%, let's say the hardcore data or the hardcore results, originates from various data sources: loop detection, throughput, cycle time. I think these were, and probably also video detection, but I'm not sure on the latter one.
Good. Thank you for your question. There was another gentleman over here with a question. Go ahead.
Yeah, but hello, my name is Heiman van Praag. I work at the Netherlands Embassy in Copenhagen as a regional business developer for the Nordics and Baltics. Yeah. Also on smart mobility, smart cities. This is a question very general, and it has nothing to do with the high-tech innovation products that you develop. But what I see is that Denmark also is one of the countries where you, when you're stopped at the traffic light and before you receive the green light, you first go to the orange light. Mm-hmm. And I just wonder, what does that make? Does that make a difference in any way compared to what we have here in the Netherlands, that it switches automatically from red to green without the orange light?
Yeah. Yes and no. These are different philosophies, basically. And a couple of decades ago, we adopted the philosophy of red and then green, and from green to orange to red. And in Denmark, they choose something else, which is also which is also actually being shown in other countries. There are different results. It could work a bit better, but.
And may I just add to that as a Dutch cyclist, I have these lights, and there's probably a technical term for this, that it says wait, and it has these lights going tick, 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 all back. So it's not orange, but it's a kind of indicating how long I would have to wait.
Yeah. It's a timer basically going from, for example, 10 to 1. And if you're able to make that really good, because I have that as well, and sometimes I think like, okay, now I'm going at 10, oh, it's now 5, and it was not 5 seconds in between. So we still need to improve that type of things. Then, yes, the how you say it? The buy-in of the cyclist itself definitely increases. Yeah.
And they do this especially around secondary schools where lots of children cycle. And they go through the red lights, and we don't want that.
Exactly.
So this is a small addition from me. We have to leave it at this. Bob, are you here for the? Are you here tomorrow as well?
Yeah.
Oh, you're here tomorrow as well.
Yeah.
So if people want to find you physically, you are at stand 02.319, right?
Yeah, correct.
And can you tell us where that is? Because 02.319.
How to? Just main interest, walk straight, and you will come by.
Okay, that way. Okay, good. This is it for now. Thank you very much, and thank you, Bob, for standing in for your colleague.
You're welcome.
Flexible, very flexible of you. Can we have a last round of applause, please, for Bob Ranstorp? Thank you for being here. If you're interested, because we heard about connected traffic management, if you're interested in CITS and in-car traffic management using CITS and moving towards autonomous driving, please stay put. And otherwise, see you another time. Bye.
Cheers.